Hi everyone, welcome back to this series. Today we're going to cover different data structures in Zig. So we're going to cover three today. We're going to cover enums, we're going to cover structs, and we're going to cover unions. So let's start with, I'm not sure why, I guess unions is the first thing I'll start with. Unions are probably the weirdest thing in Zig, to be honest. Well, the weirdest thing I'll show you today. Alright, let me go to, where are we? So what a union is, I kind of explained it last time with errors. Unions are basically a combination of one thing or another. They could actually be like, as many things as you want. Where have I actually showed this? I made too many things. Okay, get union and show unions here. And I think I also made a union up the top. Yeah, here we go. Alright, so here we have const number equals union, and we have an enum here. So putting an enum there just makes it easier, generally. You don't need to put one there. What this does is it basically allows... first, I'll explain it. So what it will do is it will save some memory, the max amount. So if you have a U32, that's the biggest size. So it will basically... It will take up a block of memory that's 32 bits. And you can choose if you want it to be small, medium, large. So 8 bits, 16 bits, 32 bits, but it will always be 32 bits. And you can choose between them. Sometimes you maybe want to do this. I haven't really found any use for doing this, to be honest, but I'll just show you how it works. Alright, so we have var number equals number. It's kind of a weird syntax, to be honest. So in curly braces, you say what it is. You say dot small. So this is a small number, meaning a U8. And I've made it 200, right? And I'm going to print the number here. And I'm going to print the type as well. Let me just, I'll just comment the rest of this stuff out, so it's just not a million messages at once. Run this, we get an error, that's good. Local variable is never mutated, of course it's not, because I've changed stuff. This is the fun of Zig, let's just change it so it shuts up. Alright, so yeah, we have number and number small equals type U8. So it's a type U8. Alright, and then, so if you want to change it, you can't just do this. You can't do this. It will give you, guess what? I didn't save it. Guess what? It gives you an error. So it says, panic, access of ununion field medium while field small is active. So basically under the hood, it's like you have like a bool which is set or an enum which is set. So here it's like small is set, you can't access medium. You can't access it. To change it, what you do is you basically you say equals number, medium, and then set the value to medium. Of course, medium, like a 1000 can't fit in a U8. So I'm not sure if, I believe it will delete the small because it's in the same area of data. So if you set a small and then set a medium, it deletes the small. So you can't have both of them active at once because it's the same block of data. Alright, so this is how you reset it. Let me just print this. So this is actually going to give us guess what? An error. Because I'm accessing small here. You can't access small because now medium is active. And you can't access small. Medium's active. So here, number small. So I have to comment the small out. And then we finally won't get an error. And we have so many error messages that I don't even know if we crashed or not. Okay, 200 type U8, 1000 type U16. So it's now a U16. So the same variable is a U16 now. And then let's do the same thing. So we make it large, large, large. Again, this will give us an error if we access the medium. Sorry, large. And then, yeah, have the large run. And again, let me clear this. Oh my god, the error messages, man. You should definitely consider a vertical monitor. Alright, so 200 type U8, 1000. So basically, it's like first it's 200 and it's U8, and it's 1000, it's U16, then it's a 40,000 and a U32, which don't fit inside each other. What am I doing next? I have no idea. Just making some new lines. Alright, so I haven't showed a switch statement, but it's not too complicated switch statements. You basically, there is a different way. I'll go through switch statements in depth later, but not now. So here I'm just printing the type of number. Like, what is the type of number? The thing is, when it actually shows you, it will say, this is a type of tutorial 1.number, which isn't really that useful information, to be honest. It's not really that useful. But say, for example, you want to get a union. Before in the errors, like, you basically have to name it. You can't just say, I want to... There's no way to actually say, this is... because you can actually, with an error, you can actually say, like, error da-da-da-da, exclamation mark, then a number type. But you can't do something like this, U8, U16. You can't do something like this because this is specifically for errors. So you have to actually make it. So you have to make a number here, and then you can use it and then return it like this. You return it like this. So now this function is returning a number, and then here I'm returning a small, which is 10. What you can also do is if you use the enum thing, then simply you can make a switch statement and just put union value, and you don't have to say anything else. It will simply know, and then just put .small, .medium, .large. So if it's small, it will show this. If it's large, it will do this, and you put it in brackets to kind of store the value if it's that. That's simply just by putting an enum here. You don't need to do anything else. If you just put enum here, you can do that. So that's a union type. They're not really that useful, I find, honestly. It's mostly just for errors. That's the only time I actually... Because you kind of have to use them when you use errors, but I wouldn't... It seems a bit too complicated for me. I wouldn't really bother. I wouldn't find a use for this. I would just create multiple variables. But anyway, those are unions. You can use them if you like. Right, so next we have enums. So one thing that's really annoying with enums in Zig is you have to convert them into integers because there's a kind of very strict type system. I actually prefer enums in C++, if I'm being honest. So let me comment this out and then show enums. Alright, where did I make an enum? I should have really sectioned this out. Here's one squares. Yeah, so basically, I made... A while back, I kind of made a chess engine in Zig just because I wanted to test it out. Wanted to see how fast it was, and it was actually pretty much the same as C++. There wasn't much difference. But one problem I found was trying to use enums. I just thought, like, what? So here I have basically something that you would use in a chess engine. It's just like an enum for the squares. And then I have some pieces which I haven't filled out, just put empty and then white king. So here I just create an array which would represent maybe pieces on a board or something like this, and I just want to set the squares. But look at this nonsense you have to write. Array, square brackets, at int from enum, brackets, square.e1 equals at int from enum pieces.whiteking. Like, why do I have to write all this nonsense? Like, it's just unnecessarily complicated. And same here. You have to... What I would probably do, because I hate this so much, I would probably just do this. Const e1 equals at int from enum pieces, so squares. And it kind of defeats the whole point if you have to do this multiple times. Then you could just put e1 here. If I could type correctly. e1. That's not a capital. That's like, because writing this so many times, it's just so annoying. It kind of defeats the whole point of me using an enum, honestly, because I don't want to have to write all this nonsense every time. If I show you the C++ example of this. So yeah, I was just showing some memory stuff. But if you look at here, I have basically exactly the same thing. Let me comment this out. Yeah, so showing enums, we call this showing enums. Alright, so here I basically have exactly the same thing. Squares, pieces, they're basically exactly the same. And here in C++, you just go E1. I don't know, like at int from enum, squares dot, oh my god, like I want to kill myself every time I'm going to write this. Because I absolutely just hate this. I wish there were a way to just simply do it for me, and why am I writing this? Like, this is just annoying. I would rather just make a constant. So what I'd probably just do is this, because I hate writing so much. I would just say const a1 equals 0, and then or whatever it would be. Because I absolutely hate writing all this nonsense when you want to use an enum. But it's the same here. It's like, how many times have I yeah, actually, quite an interesting thing. I'll show you what it prints when I let me just comment this out, because it would be an unused local constant. Um, so here, value at e1 is 1, so it's the king. Type of enum, tutorial 1.square. It's not really that useful, to be honest. But it actually, type of e1 is actually a u7. So it's made a u7. I'm not actually sure what the max value of a U7 is. There's apparently, so it's made a U7, which is 127 bits, I guess, because 64 is in between those. So I guess U7 is the safest value for this. Anyway, these are enums. They're basically like the same in most languages as const enum, and then you just put the values. You can also, I believe you can set the values, so you can set this to 0, set this to 1. It works the same way. Just the problem is, the reason why I hate using them is because of all of this nonsense I have to write. And like, there's some situations where, like, say in a chess engine, for example, there's a situation where you'd have to do something like, all right, but yeah, so you have to do this, like, say, e1 empty equals array at int from enum square e1 equals int from enum pieces dot empty, and f1 is empty equals array int from, oh my god, and it's just like, do this every time. Sorry, it should be f1. This is terrible. This is absolutely terrible. I'm just going to use constants. I'm never going to use enums for this reason. Right, now we get to structs. So structs, I made 2 examples, I believe. So structs can actually have methods. They're a bit like in C++. Let me, I can't close this because of annoying stuff. Alright, so going to structs, I believe I have a simple example. Where the hell is this? First of all, I'm going to section this out. So get unions. Alright, so we're showing structs. Okay, so first we start with math. There is obviously math in the standard template library. I'm just doing it just to show you. So we have a struct called math, which is not this, which is this, which is basically just doing what I showed last time, just adding stuff. Kind of a weird thing about structs is when you make a, I don't really know what you basically have to put self here. It's a bit like Python in a way. You have to add self, even if you're not using it. So you basically add self and then just discard it here, because it's all constants. It's all like whatever I'm not using any local variables, so I don't actually need self, but anyway, so this is exactly the same as what I wrote last time, just checking if it's I'm returning an adding error if it's an overflow or not. Otherwise, I just return them added together. And here, just add them together. Catch is 10, and then just, I actually have in the thing print result. If you want to just print it, like that, basically. So you can basically do kind of OOP, kind of, not really. There's no inheritance and stuff like this. But you can put functions in structs if you want. And then I made a user just to simulate kind of like a website or something like this. So the user has a name, a username, password, age, gender, login. See if it's logged in or not, yes or no. The gender is an enum, just male, female, other. And what else? So yeah, I made a login error and a log out error. So not logged in, obviously you can't log out if you're not logged in, incorrect password, incorrect username, and already logged in. And I have some login functions in this. So we basically, you don't actually need to make a constructor when you're making a struct. You can basically do it when you declare it. So you can do math like this, but it doesn't have any function, doesn't have any local variables in the struct, so you don't actually need to write. But if you do have it, you can set them default like this. You don't need a constructor. You can say user1 user equals user, and then in the curly brackets you put .name with commas. So here I've just, yeah, obviously you shouldn't, store a password like this. This is just an example. Storing a password like this is a terrible idea. Just an example. And then we just call user1 dot attempt login, which goes to here, attempt login. I believe it needs to be public, but I'm not sure exactly. I'm not really an expert on structs myself. I believe it needs to be public, so we have a login result, basically just trying to log in. Did we log in or not? And it returns an error or just a void. So it returns a login error or a void. So if we're logged in, we're already logged in, return the error. We get the length of the username and we get the length of the inserted username. So we put the username in and we're basically testing it against this username. Then we do the same for the password, so we get the username and compare the length. So obviously, if they're not the same length, so if the username isn't the same length as the username put in, then it's an error. Then just go back, and same with the password. And then we just simply for loop and go through them. I'm not sure if there's a way of more efficiently checking memory. Probably there is in the standard template library, but I'm not going to use a standard template library because it's normally well, it's not the best to show examples. So check if the usernames are the same. Check if the password the same. If they are, then we just go to the end of the function and it's successful. Here we don't actually return anything. We return void. So this function returns a void. So we can't use, there's nothing to print, so we just put nothing there. And then we have the error if there is an error. And then, so after we try to log in, then we try to log in again. And that should say already logged in. Let me, am I calling this? I am calling this, so let's see what happens when I run this. Error expected, where is this? Ah, I understand. Sorry, I didn't put this. That's why it wasn't working. Now it works. Okay. That was the error. That was why. Okay, so here it says successfully logged in. I should probably put the username there, but I'm lazy. Login error. So we try to log in again and say already logged in, error. Successfully logged out, and then we try to log in with the incorrect password, and it says incorrect password. Because we put 124 instead of 123, which is the actual password. This is a basic explanation of how structs work. For some reason, like I'll show you, if I take away the self, let me go to math. Very, very big function. The problem with one problem with Zig is like if you're very thorough and check for errors, then you have a lot of like all of this. You write a lot more than if you would write it in JavaScript and not care about errors and stuff. But safety means you write more, basically. All right, so if I go to the number, sorry, not number, it's math. If I go to math, struct, if I take away self, it will give me an error because of course it does. Of course it, this is Zig, right? It gives you errors. That's what it does. Take away self, even though I'm not using self at all, it will still give me an error. See, it gives you an error. Let's see, it says no field or member function named add i32.math. You basically need to include self, otherwise it won't work. And I don't actually know why, to be honest. So self, math, brackets, and then we don't even use it. So what's the point in, I don't know. But you don't actually need to, when you call the function, like when you call like the function, you don't actually put user in, or you can put the self in. It does it for you, because you're calling it from this instance. So this is an instance of math, so it basically puts the instance in for you. You don't have to actually write. Because in theory, you'd have to do math, but you don't need to do that. Also, if you make it so in the user class, it's not a class, it's a struct, but in the user struct, I've actually made user a pointer, which I haven't gone through pointers yet, but it works the same as in C and C++. I made it a pointer, and it didn't actually change the code at all. So you can make it a pointer. The reason I made it a pointer, well, one, it's kind of costly to copy a struct, because it's like, so here we have a constant U8 slice, which could be something. Let's say, I don't know, an estimate. This would be something like, I don't know, 100 bytes or maybe 50 bytes or something like this. A pointer is a lot less than that, so anyway. So the reason why I used a pointer, one, it's easier to copy, but also I'm actually changing a value. So I'm changing the logged in. So if I actually log in, if you attempt to log in and it's true, and you set the login to true, so I need to use a pointer, otherwise it won't, it won't work. So if you send something as a pointer to another function or a reference or a pointer, then you can change it and it's not constant by default. All right, so that was just a few data types that we have in Zig. Um, Unions are pretty rare, honestly. I wouldn't really use unions myself, but you can if you want. They can be useful in some situations. Enums too. I honestly, I will lose the will to live if I have to write this nonsense, and this nonsense. This is terrible. Uh, but I guess maybe it's safer? Question mark. I prefer the C++ way of doing it, but anyway, that's all for this. I'll see you guys next time.